Hopefully you've used the quadratic formula before, but let's run through one example of it. Suppose we want to know what values of x makes 3 times x squared minus 7 times x equal to 4. Now, this is not in standard form. The standard form is ax squared plus bx plus c equals 0. So you have to move everything to one side of the equation. And that gives you subtract 4 from both sides and you get 3x squared minus 7x minus 4 equals 0. We usually put the x squared term first and then the x term and then the constant term so that the 3 is the a, the negative 7 is the b, and the negative 4 is the c. Now I'll write those out again. A is 3. It's not the 3x squared. It's just the thing in front of the x squared, just the 3. Similarly, b is negative 7, not negative 7x. That's a very common mistake for people to make. And c is negative 4. Now, the formula that we arrived at the last video is x is negative b plus or minus the square root of b squared minus 4ac over 2a. So in this particular case, x is negative b, which is negative 7, plus or minus the square root of b squared, which is negative 7 squared, minus 4 times a times c, 4 times 3 times negative 4. And that whole thing is over 2a, which is 2 times 3. You have to simplify this. Negative 7 is positive 7. And negative 7 times negative 7 is 49. This is different than negative 7 squared. The whole b is being squared. So whether it's positive or negative, it's always going to turn out to be a positive number. Let's see. 4 times 3 is 12. 12 times 4 is 48. We have two negatives. It becomes positive. All over 2 times 3, which is 6. 47 plus 48, this is 1 away from 50, this is 2 away from 50. Together you're going to get 3 less than 50 plus 50, which is 97. So you get 7 plus or minus the square root of 97 over 6. And that means that we have two different answers. We have 7 plus square root of 97 over 6 and 7 minus square root of 97 over 6. If you want to know these more intimately, you'd say, what are these? You say 97, the square root of 97 is something crazy. We add 7 to that and we get that. And we divide by 6 and we get 2.808, let's say. So here x is approximately 2.808. It's a little bit more than that. And let's see, 7 minus the square root of 97. I'm going to do the square root first. Square root of 97, and then I'm going to make it negative, and then I'm going to add the 7. There's other ways to do that. And you divide that by 6, and you get negative 4748. I like to stop right there because you don't have to do so much rounding with a 0. Negative 4748. X is approximately negative 0.4748. And what was our original equation? Our original equation was 3x squared minus 7x minus 4. 3x squared minus 7x minus 4 equals 0. And what do we get? Well, if 2.808, what is that squared? We get 2.808 squared times 3 is some number, minus 7 times 2.808 is, and then we subtract 4 and we get remarkably close to 0. We get 1,000th, 14 10,000ths. We get no ones, no tenths, no hundredths. So pretty close because we only approximated. 4748, what do we get? 0.4748, but it has to be negative. Well, when I square that, it makes the negative not matter. You square that, you multiply that by 3, and you get that. And then you subtract 7 times that thing, which is 0.4748. I have to put my negatives at the end because I'm using a cheap calculator. Equals, and then when I subtract 4 from this, I again get a remarkably small number. It rounds up to 1/10,000th. It's close to 0. And that's why we say that these are two answers. Now that's why I use the little squiggly equally signs, the approximately equal But the correct answers, if you use these exact answers, it will come out to be exactly 0. So it's a useful formula, and it enables me to talk about the ancient Babylonians. And I would say if you have a decent grasp on the quadratic formula, then you have a decent grasp on algebra. And if you can prove it, if you can follow the proof, you have a better than decent grasp on algebra. And if this is the last math class you ever had, wouldn't it be great if at some point during it you understood sort of the keystone of algebra as we know it?